Good morning, everybody. Thank you all for coming out. And I wanted to thank Rosenthal and Mallory and the rest of the ISOJ team for organizing this great conference. So what I'm talking about today, what's next, is machine learning / AI. What we're going to talk about is like what the heck these things even are. Because like Zach was saying, it's a big buzzword. Everyone is claiming that they're using it. We're going to talk about some examples of how machine learning and AI are actually being used by journalists in newsrooms today and in the past couple of years. Sort of theoretically how you'll be able to use these. You could use them now or in the very near future, as well as some ways in which these technologies being used by people outside of journalism are going to cause us some problems in ways that can be pretty scary. So to start off, what even is machine learning? It's math. It's just math. It's really fancy math, but it's not magic. It's just math that you could probably understand if you took like a bunch of classes and got a PhD. But I definitely don't have that PhD. Most machine learning practitioners have no idea how this works from a mathematical perspective. So it can seem like magic, even though it's just the computer is manipulating some numbers in some ways that you don't understand. But what it's doing is it's finding patterns. You're giving it a bunch of data that encodes some of your hypotheses about some sort of pattern that might exist. Some sort of pattern that you hope is meaningful. Maybe there's a couple of hypotheses in there, and that the answers about what patterns actually do exist in the data that you have are going to be useful to you in some way. For us as journalists, hopefully that means that we've found something out about the world that we didn't know before, that the computer is telling us. So what is AI? It's the same thing. If you say, oh, we use artificial intelligence, what that probably means is you're trying to raise money. Machine learning is just sort of what the mathematicians and the programmers call it. AI is what the marketers call it. There's a little bit of difference if you're like a philosopher. But for our purposes, it's the same thing. I'm going to say machine learning because I'm a computer programmer, sort of by trade. But if you're curious about artificial intelligence, just pretend that's the word I'm using. So how is it that your organization can benefit from machine learning? This is not my metaphor, by the way. I'm copying it from someone. I don't know who, but it's not my idea. So imagine that you had unlimited interns. Think about your intern for next summer, your intern from last summer. Unfortunately, they probably had some sort of kind of menial task to do, reading a bunch of documents, making a bunch of phone calls, and they probably impressed you with how bright they are. They did a really good job. They knocked the ball out of the park. Imagine you had unlimited versions of that intern, except they can't make phone calls and they're not that bright. All they can do is that sort of menial task. That's what machine learning is. You're getting the computer to do some sort of really menial task that you could never get so many interns to do it, but it's just sort of reading a document and counting up the words, or measuring some piece of data a gazillion times. You can't get a person to do that, but the computer will do it happily. So here are some examples, the real-life examples of journalists using machine learning to help them do their jobs, to break news, investigate, find the bad guy, that sort of thing. My first example is a story from about a year and a half ago by the Atlanta Journal-Constitution. They started off just looking at Georgia, because they're in Georgia, but they expanded to the entire United States. They downloaded all of these documents from all of these state medical boards, which publish these documents about how doctors who are disciplined, what happened, what the case was that they were charged with doing that got them to maybe lose their license or temporarily lose their license. And they found that a lot of these people had moved from state to state to sort of dodge these sanctions. And what they were most interested in was not the doctors who had been sort of doing something funny with their money, or doctors who had been prescribing opioids to people they shouldn't have been, or prescribing too many of them, but rather doctors who were sexually abusing their patients. But the problem was, they had 50 states worth of bad doctor paperwork going back years and years. And so what were you going to do? You can't have a handful of, I guess there are 4 people's names on this story. You can't spend 4 of your top-notch investigative people reading all these documents for like an entire year. That'd just be a waste of time. So instead, what they did was they built a machine learning system to search through all of these documents to find, it's sort of hard to read in the small text, but read through all these documents, looking for all of these words that might indicate that this was a sexually abusive doctor, or might indicate that this was a doctor who was doing some other bad thing that was not super relevant. They trained a statistical model that says, oh, if you have all these words about genitalia or whatever, it's a lot more likely that it's going to be a sexually abusive doctor. And so what this was it was able to sort of separate the computer was able to separate the wheat from the chaff. So instead of reading millions of documents, or however many it was, they only had to read 10% of those, or something like that, which saves them a lot of time, and they were able to do this amazing story that exposed a lot of really bad doctors that was really in the public interest. So my second example is from BuzzFeed. Peter Aldis, who was mentioned earlier in a question, really great data reporter. I think that as was mentioned before, the code from this is on GitHub probably. They were looking for these aircraft that are connected probably to the government through some shell companies that are circling over American cities, doing something sketchy, kind of like surveillance. Maybe it's cameras, maybe it's cell phones. Not really clear, but Peter was able to track down a bunch of these planes. The problem was that they had gotten a gigantic database of the flight paths of like every aircraft over the United States for a year. This is a huge amount of data with like, the guy who flies on Sunday with the plane he built in his garage, commercial airliners, rich people and bankers flying around, helicopters with medevac and the TV helicopters. How do you separate out the actually sketchy airplanes that they were looking for from this gigantic mess of data? Again, you probably could have had interns go through and look at every single flight path. Is this a Delta plane? Is this some banker just flying from the Hamptons to Miami? And it would have taken way too long. So instead, they found some way to represent each airplane's flight path. Some stuff about how often did it change altitude, how much distance start to end did it cover versus the amount of sort of linear distance that it flew. So these sort of hairballs here are where it didn't cover a lot of distance over a long period of time. It was able to, again, separate the wheat from the chaff in terms of finding which of the aircraft's flight paths were most interesting. So then a human could apply their knowledge to that to say, oh, this one really is a sketchy airplane. Here's a project that I did. We had a gigantic database of press releases from Congress. And I used this machine learning tool to ingest all of these press releases of, we renamed the post office or whatever it is, into a system that sort of learns a little bit about how English works. And you can compare the average of all their press releases, or the average of the words in each press release, to get an idea about what it means. And so this system, without me teaching it a whole lot, just feeding in half a gigabyte of press releases, it was able to learn that Representative Paul Ryan cares a lot about taxation, which, if you follow US politics, he's obsessed with tax policy. So the computer was able to learn this all by its own. Chuck Schumer, likewise, knows a lot about, or spends a lot of his time on transportation. But what you've got to be careful of is that what the computer thinks is interesting might not be what you think is interesting. Using a similar tool to this, I compared a few years of ProPublica articles, which is where I work now, to a few years of articles from the New York Times, where I used to work, to see what was most distinctive about ProPublica's articles. I'd hoped it would be something like some topic of a ProPublica investigation. No. The most distinctive word from ProPublica compared to the New York Times is the word spokesperson. Why? New York Times style demands that you say spokesman or spokeswoman. New York Times, or the ProPublica allows spokesperson. This is sort of interesting if you're a copy editor, but it's not the like hard-hitting fact that I was really hoping for. So you got to be careful about that with machine learning. So I'm running out of time, but you probably already have some machine learning experts in your newsroom. They're in charge of your A/B testing. A/B testing is sort of rudimentary machine learning, and even more complicated ML techniques are being used to maximize your ad sales, your page views, these sorts of things. And I bet you that those people on your business side would love to spend a couple Fridays teaming up with a reporter to find something really cool. But here's what you got to be careful of. People outside of your newsrooms are using sort of the combination of virtual reality and machine learning to create these really convincing fake videos. Here's a screenshot from the New York Times of Kevin Roose pasting his face onto some famous guy, I don't know. And you generate these really, without a whole lot of effort, can generate these totally convincing fake videos and totally convincing fake audio. You can make President Trump or former President Barack Obama say whatever you want them to say. And it sounds totally convincing. And I don't know of any examples of this fooling journalists yet, but like that's going to be coming because it takes a couple hours and $80 to make one of these. And some of these trolls who were mentioned in yesterday's sessions are gonna, find $80 somewhere and build one of these and try to fool you. And that's really gonna be a problem because you can't rely on the fact that it's a video. You can't rely on the fact that it really is audio and it really sounds like, oh, it's a leaked tape of Obama saying something terrible, because it might just be someone who applied these fancy computational techniques to generate some scary fake propaganda. So machine learning and AI, it's really useful for investigative reporting. Your newsroom's probably already using it, and you can get some impressive results if you have those people team up, but you got to be careful of those scary deepfakes.